Hey y'all, happy Monday. I am super excited to see you today. It is day, I don't even know anymore of quarantine, but I wanted to tell you a story about my friend. So my friend, she got a dog for the quarantine because she was lonely, she's an extrovert, she needs something to do. But she can't take her dogs for walks anymore because it keeps getting attacked by ducks. So, it's on her. She shouldn't have bought a purebred. Hi y'all, so today we're going to be talking about the Pythagorean theorem. So we're bringing together a bunch of stuff that we've already learned about. We've already learned about the Pythagorean theorem, it's a squared plus b squared equals c squared. We've already learned about rational approximation so that we can tell about what a square root is going to be if it's not a perfect square. And we've already learned about finding the distances between points on a coordinate plane. So we're going to put all of that stuff together today. And let's get started. So these are my 4 points from Wednesday, how I found the side lengths between the points. And it's just the difference between the x values and the difference between the y values. So my difference between x values is 4 minus -6 minus -6 minus a negative is a positive, so that gives me 10. And the difference between my y values is 1 and -4, and 1 minus -4. Remember, a negative minus is a positive, so we end up with 5. So the distance between my x values is 10, the distance between my y values is 5, and I'm going to use that in the Pythagorean theorem for, if I had this rectangle, 4, 1, 4, -4, -6, 1, -6, -4, what I'm going to find is the distance between these 2 points. These 2 points right here. And I'm going to use the Pythagorean theorem to do it. So my Pythagorean theorem is a squared plus b squared equals c squared. My a value is 10 squared, and my a value comes from right here where I just drew on. This is my a value, which is going to be 10. And so my b value is like this segment right here, b value. And in this case, it is 5. So my b value is 5 squared from the formula equals c squared. 10 squared is 100 plus 5 squared is 25 equals c squared. 100 plus 25 is 125 equals c squared. And I'm going to take the square root of both sides. Now 125 is not a perfect square, but I know that it falls somewhere in between 121, which is a perfect square, and 144, which is a perfect square. Now the square root of 121 is 11. The square root of 144 is 12. So I know that the square root of 125 will fall somewhere between 11 and 12. And I see that it's closer to 121, so I'm going to try, how about 11.2?
So I'll try 11.2 times 11.2. 2 times 2 is 4, 2 times 1 is 2, 2 times 1 is 2, x is an O, 1 times 2 is 2, 1 times 1 is 1, 1 times 1 is 1, 2 x's, 2 O's, 1 times 2 is 2, 1 times 1 is 1, 1 times 1 is 1. And I'll add them all up. 4, 4, 5, 2, 1, and I see 2 numbers after decimals up here, so I put 2 numbers after decimals down here.
This gives me 125.44, which is pretty darn close to 125. So the square root of 125 is approximately 11.2. So that means that 11.2 is my c value, which means that it is 11.2 units away to go diagonally between these 2 points. Let's try another example. So sometimes the problem will only give you 2 points, and they're not going to be a nice straight up and down or a straight horizontal. They're going to be on somewhat of a diagonal, and they'll ask you what the distance is between these 2 points. And the way that we find it is with the Pythagorean theorem. So when you have 2 points like this, you need to add a 3rd point to turn it into a right triangle. Now remember yesterday how we noticed that 2 of the points had the same x value and 2 of the points had the same y value, and so we found the difference in the stuff that was different? We're going to add a 3rd point that takes the x value from one of the points and the y value from the other point. And that's going to be the 3rd point on our triangle. So now what we're going to do is find the difference of the x values and the difference of the y values. So my 2 x values involved are 3 and 4. 3 minus 4 is -1, and we can't have negative difference, so it's actually the absolute value. We're just going to make it 1. And the difference of our y values is -2 minus 1 is like saying -2 plus -1, which is -3. And again, we can't have negative difference, and it actually is an absolute value function. So our side lengths are 1 and 3. And we're going to plug these values in to our Pythagorean theorem. A squared plus b squared equals c squared. Our a value is 1, so 1 squared, plus our b value is 3, so 3 squared equals c squared is the value that we're looking for. 1 times 1 is 1, plus 3 times 3 is 9, equals c squared. 1 plus 9 is 10, equals c squared. And if we were to find the square root of 10, because we're taking the square root of both sides, the square root of 10 is somewhere in between the square root of 9 and the square root of 16 are the 2 closest perfect squares. Well, I know that the square root of 9 is 3, and the square root of 16 is 4. I know that the square root of 10 is somewhere between 3 and 4. And I know that 10 is much closer to 9 than it is to 16. So let's try 3.1.
3.1 times 3.1. I got 9.61, which might be pretty close. Let's try going a little bit higher to see if we can get any closer. Let's try 3.2 times 3.2. I got 10.24.
And 10.24 is much closer to 10 than 9.61. So my C value is approximately 3.2. So approximately 3.2 is my C value. And I know that that is possible because my C value should be the longest distance, and 3.2 is higher than 1 and 3. So this is a possibility to be my answer. I want to show you on a graph how I found these differences, these side lengths. So I'm going to make some space. If you have a piece of graph paper, go ahead and take it out. If not, please sketch this graph with me. have just made a little graph that goes up to 5 in every direction. And I'm going to plot these two original points. So I have 3, -2, which is 1, 2, 3, 1, 2, which is right here. And I have 4, 1. 1, 2, 3, 4, 1. And I was looking for this distance, this diagonal between those 2 points. But in order to find this diagonal, I had to use the Pythagorean theorem using an additional point that I would put right here to make this a right triangle. And if you notice, the distance between these 2 points is 1, just like I said, and the distance between these 2 points is 1, 2, 3. I also want to say, please make sure that you are putting your real name on your quizzes and your Flipgrid assignments. I can only give you a grade if I know that the grade belongs to you, so please use your real name on both of those assignments.